Guys, my name is Brianna Flores, and I'm going to be talking about the atomic structures of alcohols, ethers, thiols, ketones. So as the title suggested, I'm going to be talking about the oxygen-containing functional groups. And aldehydes and ketones belong to what's called a carbonyl group. So I'm going to be giving you a little bit of detail about what a carbonyl group is. Before I get into this, I need to mention some important background information. So a functional group is a group of atoms found in molecules that give them their characteristic chemical properties, and I will be going over functional groups that contain oxygen. Another thing we need to remember is that hydrocarbons are compounds that contain only hydrogen and carbon, and they are very stable. However, by adding oxygen, which is a very reactive element, we will also increase the compound's reactivity, and as a result, many of the reactive carbohydrate molecules will contain oxygen. Another few things to remember about oxygen is that it can form compounds with all of its elements. It has a bonding capacity of 2, and it can either make strong single or double bonds with carbon. So why is this important? As I said, they determine the molecule's characteristic reactions, so how they're going to react in chemical reactions or some of their physical properties. And they also form many important organic molecules that make up our DNA, proteins, hormones, beverages, and a lot of things. They're all over the place. The first functional group I'm going to be going into is going to be the alcohols. So alcohols will be a carbon-fabric molecule in which a hydroxyl group places the hydrogen side on the hydrocarbon. They're going to have the suffix of OL, and they're going to be classified into 3 groups based on what the carbon bond to the oxygen is attached to. So the primary alcohols are going to be attached to 2 hydrogens, the hydroxyl group, and an R group. The secondary alcohols are going to be attached to 1 hydrogen, the hydroxyl group, and 2 R groups. And a tertiary alcohol is going to be attached to a hydroxyl group and 3 R groups and no hydrogens. So just a quick reminder, an R group is any group in which carbon or hydrogen is attached. So thiols. Thiols will look just like alcohols, but instead of having an oxygen group attached, they will have sulfur. So instead of them having an OH bond, they're going to have an SH bond. That's their main difference. Additionally, they're going to have an SH bond, which is going to be longer. So if you look at the sizes of both of these atoms, the sulfur is slightly bigger than oxygen, meaning the bond is going to be longer and weaker. As a result, they're going to be stronger acids, which means they're going to be able to donate hydrogen ions more easily. Ethers. So an ether is when you're going to have an oxygen in between 2 alkyl chains or groups. So you may be wondering what an alkyl group is. Remember that hydrocarbons that are only made up of single bonds are called alkanes, and alkanes that are missing 1 hydrogen are referred to as alkyls, as the picture shows. So in other words, ethers have an oxygen in the middle of 2 R groups. The charge distribution, so oxygen is going to have a higher electron density, which is going to make both carbons partially positive. The last 2 functional groups I will be talking about belong to the carbonyl family. This means that they will contain what is called a carbonyl bond, which is a very polar carbon-oxygen double bond. It's important to note that the oxygen will draw electron density away from the entire molecule. The carbonyl family will also have 2 other atoms attached to the carbon atom and will make the compound trigonoplanar, with bond angles of 120 degrees. As a result, there are many different types of carbonyl compounds, each with different properties. Specifically, I will be going into the detail of 2 of these, aldehydes and ketones. Aldehydes will have a carbonyl bond and a hydrogen attached to its side. This functional group must always be at the end of a carbon chain because hydrogen only has a bonding capacity of 1, and oxygen is also satisfying its bonding capacity of 2. Aldehyde is written as CHO in condensed formulas and has the suffix of AL for aldehyde. Finally, if you notice their structure, they're not very far away from being an alcohol. In fact, aldehydes can be converted into alcohols and vice versa, and they are also very reactive. Finally, I will be talking about ketones, in which there is a carbonyl bond and 2 R groups attached to both sides. The ketone suffix is -one, as in ketones. They can also be easily oxidized, and they are less reactive than aldehydes. This is because their R groups tend to donate some of their electron density to the carbon instead of to the oxygen, like in most functional groups, resulting in the carbon being less positive than in aldehydes. The goal of this video is for you to be able to identify the different functional groups found in molecules. So here's a little exercise. Just try to identify the functional group on each of these molecules, and I'll give you the answers in a few seconds. So this is a good time to pause the video, pause it now. So these are the answers. Hopefully you got them right. I highlighted in yellow the important things that would give away what functional group it was, and I included some molecules that have more than one functional group because it is possible to have more than one functional group in a molecule. Thank you very much for watching. I appreciate your time, and I hope you have a nice day.